Hi everyone, in today's lesson we're going to talk about graphs of exponential functions and logarithmic functions. By definition, a logarithmic function is the inverse of an exponential function. Since all exponential functions are in the form y equals b to the x, the inverse would be x equals b to the y. If you recall, the inverse tells us to switch the x and y values. Okay? So if we had an exponential function that's y equals b to the x equals b to the y would be the log function. Okay, so let's look at this picture right here. This picture shows an exponential function here, the line y equals x, and the inverse function, which is the log. So all exponential functions look like this, and all log functions look like this, and they go through, or they reflect over the line y equals x. So all exponential functions will have a specific asymptote. And here, if you look, the asymptote, it looks like this graph is approaching the line y equals 0, but it's never going to touch it. So that's the asymptote for an exponential function. And the domain of an exponential function is, well, how far to the left does it go and how far to the right does it go? It looks like it goes forever left, and it will go forever up and to the right, so the domain is from negative infinity to positive infinity, or all real numbers. Now the range of an exponential function, well, it looks like it's going to start at 0 and go up. So we would say the range is from 0 to infinity. And the 0 gets a parenthesis around it because it's an asymptote and it'll never touch it. Okay, now let's talk about the end behavior. So the end behavior says it's always in two parts, as x goes to negative infinity and as x goes to positive infinity. So let's look. As x goes to negative infinity, f of x is headed where? Well, it looks like the graph is headed to the line y equals 0. It's not necessarily headed down to negative infinity, so we say that f of x heads to the line y equals 0. So look, as x goes to the left, or as x goes to negative infinity, this graph is headed all the way down to the asymptote. Okay? Now as x goes to positive infinity, f of x looks like it's shooting up, so we say f of x goes to infinity. Now, common point. What do I mean by that? A common point is a point that all exponential functions will have in common. Exponential functions will all go through this point 0, 1. And let's show you why. So this example right here is the graph y equals 2 to the x power. So if x is 0, I want to know what y is. So f of x is equal to 2 to the x. Say I want to find f of 0, 2 to the 0. Anything to the 0 power is 1. So if I had a different exponential function like 10 to the x, so if I did 10 to the 0, it would still be 1. Or 12 to the 0, 6 to the 0. No matter what exponential function I have, anything to the 0 power will always be 1. That's why it goes through that point there. Okay, now what quadrants are exponential functions in? Well, it looks like, if you recall, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so it looks like exponential functions go through quadrants 1 and quadrants 2. Okay, now let's analyze logarithmic functions. So a logarithmic function looks like this. It's a reflection over the line y equals x. The asymptote now, it looks like as this graph is approaching the y-axis, but it'll never touch it. That's the line x equals 0. So notice anyway that exponentials and logs are inverses, so the x's and y's should be switched. Alright, so let's look at the domain. The domain looks like it doesn't pass the y-axis, so the domain is from 0 on. So we say the domain is from 0 to infinity, and the range, how tall this thing is, it goes up forever, down forever, so negative infinity to infinity. And again, that makes sense because if domain is the x value, and I switch the x and the y, then the domain becomes the range, and the range becomes the domain. Okay, let's talk about the end behavior now. and behavior again is in two parts, as x goes to negative infinity and as x goes to positive infinity. So as x goes to positive infinity, f of x goes up. So goes to infinity as well. And as x goes to negative infinity, where is this graph headed? It's headed to negative infinity. Okay, common point is a little bit different. So if the common point here was reflected over the line y equals x, this is the new common point. So all log functions will go through the point 0, 1, and they will stay in quadrants 4 and 1. Okay, now let's talk about different types of logarithmic and exponential functions. We could say that logarithmic functions with base 10 are called common logs. So when the base is not indicated, a base of 10 is implied. So you're going to see, you won't see log base 10 of x. You'll just see log of x. So you won't see this, you'll see this. You have to know that if I have a log of x, it implies log base 10. Okay, so this is a log base 10 function. Looks this way, where the asymptote's here, goes through the common point 1, 0. Now, logarithmics with a base of e is just a number. It's in your calculator. Remind me tomorrow and we'll go over it. E is almost like pi. E is equivalent to 2.718, I think, something like that. That's what e is. So it's just a number. So when I take y equals e to the x, it becomes exponential. And then when I take the inverse over the line y equals x, it becomes an ln function, which is a log function. So it's a log, which is base of e. But again, you won't see log base e, you will see ln. So when you see ln of x, you need to say this is the same thing as saying log base e of x. Okay? Alright, now I'd like to go back up here and just talk about how to change from exponential to logarithmic. If you took Algebra 2 last year, this should be a little bit familiar to you, but I'd like to review it again. So remember how we said that a log is an inverse of an exponential. So if I have y equals 2 to the x, the inverse is x equals 2 to the y. But x equals 2 to the y is not what we call logs. This is how we write logs. So we have to understand that the base of the exponent becomes the base of the logarithmic function. So instead of saying x equals 2 to the y, we're just going to say y equals log base 2 of x. So this whole front page, I know it's a lot of information, especially if you're in Algebra 2 for the first time. So it's a lot to sink in. It's just characteristics of both exponents and log functions. But what we need to be able to do is this last piece right here. We need to be able to convert exponents to logs. So let's go to the next page. The next page is all about doing that conversion. So if I have a log, can you make it into an exponent? Or if I have an exponent down here, can I make it into a log? So the way that we convert them is using this loop-de-loop method, what I like to call. So we're going to circle the base. We always start at the base, go up to the answer, and come back to the exponent. So this would be b to the a power equals e. All right? So watch. We start at the base, we go up to the exponent, back down to the answer. So b to the a equals e. b to the a equals e. So let's put it into perspective with a few examples. So this one would be 9 to the second power equals 81. And does it? Good. So 9 squared equals 81. All right. Now, number 2, log of 1,000. Again, this is your common log. There is no base, so you have to assume a base of 10 is written. So again, we start at the base. 10 to the third equals 1,000. And does it? Yep. Perfect. Okay. Now we have an ln example. So we need to remember that ln is a log of base e of x. Okay? So now we can do the loop-de-loop. We start at the base. E to the third equals x. All right. Now, how about number 4 and number 5? Number 4, there is no equal sign. So we will just say, what is this equal to? What is this equal to? We could use x, right, if we want to. So ln of 4, remember, is the same thing as saying log base e of x, or excuse me, log base e of 4 equals, we'll call x. So again, we start at the base. E to the x power equals 4. Same thing with number 5. Start at the base. 5 to the x power. Don't know why I wrote e, sorry. So 5 to the x power equals 1 over 25. Okay, see if you could do 6 through 10. And then hit resume when you're finished. Okay, here are your answers. So for number 6, you should have remembered that ln is log base e. So it should have been e to the 4th equals 5x squared. Number 7 was switched. That's okay. You'll just take the base, go this way now, and come back down. So 16 to the 1/2 equals 4. Number 8 was a common base of 10. So log base 10 of x squared. We don't know what that equals, so we could say 10 to the y equals x squared. Can't use x because x is already there, okay? Number 9 is log base e as well. Log base e of e equals 1. So let's write loop-de-loop. Start with the base, e to the 1st equals e. Same thing here, log base e of 1 equals 0. E to the 0 equals 1. And are all these statements true? Yeah, e to the 1st is e to the 0 is 0. 16 to the 1/2, or the square root of 16, is 4. So these are all true statements. Okay, let's move on to the next set of problems, going backwards now. So can we write this as log base whatever of something equals what? Log base of what? Okay, so let's start with this first one. We always say that the base of the exponent is the base of the logarithmic. So this is log base 2, log base 2, log base e. So we have 2 to some power equals what? So you could just look here, 2 to the 3rd. So 2 to the 3rd power equals 8. Now let's look here. We started with the log, we wrote the base. 2 squared is equal to 4. So let's write backwards now. 2 squared, 4. Same thing with e. E to the 5th equals x. So where does this go? E to the what equals this? So e to the 5th equals x. This one can also be written as ln of x equals 5. Probably more appropriate because remember log base e is ln. Okay, number 4. Log base e, or we could say ln. All right, so e to the what power equals what? So e to the 4th, so 4 is going to go here, and 2x is going to go here. And the last one, here's my base, so log base 25 of something equals what? So 25 to what power gives me what? So the power is 1/2, and the x goes here. Okay, why don't you see if you can do 6 through 10 and hit resume when you're finished. Okay, here are your answers. All right, take a minute to jot them down, and if you have any questions on any of this, please ask tomorrow. Have a good night.